Hello everyone, and welcome to the official AP Statistics Review sessions. This first video is going to be reviewing Chapter 1 and 2, hopefully all in the same video as the plan unless it goes longer than I think, but it should go pretty fast. These are just highlights, so if you feel like I said something that you don't remember, you need to go get your unit notes out. Hopefully you have them. Also, I'm planning on posting Khan Academy videos that correlate, so if you ever need more of an explanation, you can go watch those or contact me. I am going to start doing Zoom conference calls for if you have any questions as you're working through either questions in this packet or on the AP Classroom assignments. So there are resources if you feel like I don't touch on something enough. So Chapter 1 was, remember we first learned Chapter 3 then we went back into 1, 2, but now we're just going to go through in order. So this wasn't the first one we learned, but Chapter 1 was over graphing variables, but most of the time it's quantitative, but we talked a little bit about categorical and describing your data. So it's important, it seems basic, but it's important to be able to determine, is your variable either categorical, like something's wrong there, or quantitative, right? So if it's categorical, then it's something like favorite color, or even, it's normally, not numbers, but it's placing people's in groups. So even zip code, even though that's a number, it would still be categorical. It's just groups or categories, and you measure how many fall in each group or each category. Now, if it's categorical, you should be using a bar graph. Okay, so you cannot use any of these options on an AP test if it asks, this is your variable, what graph should you use? Well, you determine if it's categorical, you need to pick bar graph. If it's quantitative, then you can probably pick any one of these. It just kind of depends on, is it big spread? You'd probably pick histogram. Stem plot is if they share a bunch of those same stems, like the tens number. And then dot plot, box plot is just kind of, I don't think you would get a question asking about that. So is it categorical, so that'd be one categorical variable or one quantitative. This unit was all just one variable in a problem. Because if it was two categorical variables, that would be a two-way table, which we're not going to use in this chapter. And then if it was two quantitative variables, that would be a scatter plot, one on X and one on Y. And that's Chapter 3. So just to keep in mind, this whole unit is either one categorical or one quantitative. So you just have an x-axis. Now, for a bar graph, you might have a y-axis, but that's just your quantity. So if it's quantitative, you can pick either of these options. And hopefully we all remember what those are, and you can go back and look in your notes. So when you describe it, you need to talk about center, shape, spread, outliers, and also with outliers you could say gaps. And so then also with that, you can also choose your numerical summary, and we'll get more into this, I think, later down here. But if it's not skewed, so that's when it looks like approximately normal. That's when we use mean and standard deviation to talk about it. If it's skewed, it's best to use your 5-number summary, which would be your minimum, your Q1, your median, which is like Q2, and then your Q3, and then your max. So I don't know if y'all remember how to get that, but you would label them from least to greatest. Obviously your smallest is your min, your largest is your max. You find the middle, and that's your median, and then you find the middle of the first half, which is your Q1. The middle of the second half is your Q3. So after you finish displaying the data or displaying the distribution, there are some things you need to look for. So you need to look for the overall pattern and major deviations from the pattern. Also, words that aren't on here is like bimodal if it has 2 peaks, or unimodal if it has 1 peak, or uniform if it's just flat across, it would be uniform. If you want to write those down, you can. And then you're going to assess from your graph whether the shape, so you need to decide what the shape is. Now, we always list it center, shape, spread. It doesn't matter the order, but it's actually probably best to determine the shape first, so then you know what center to use. So you determine the shape. Is it going to be roughly symmetric or skewed or neither? And then you assess if it has more than one peak, which is what I was just talking about. Then after you determine the shape, you're going to describe the overall pattern by giving numerical measures. Okay, you need to actually give numbers when you talk about the center and the spread. In addition to that verbal description of your shape. And so then you decide which measure of center and spread is most appropriate based on the shape. So again, if it's symmetric, you would probably want to use mean and standard deviation, or 5-number summary if it's skewed, which 5-number summary isn't spread. So within that, you would want to talk about range. For the spread, you'd want to use range and IQR, and the median for the center. And then you also need to talk about any outliers. So if you can, now if it's just a graph and you can observe what the outlier is because it's just obvious, but if it says determine if it's an outlier and that's the question, you want to make sure you use these formulas. So to find the low, this is for a low outlier. You do Q1 minus 1.5 times that IQR, which we'll talk about down here if you forgot what that is. And then this is to find the high outlier would be Q3 plus 1.5 times your IQR. And so anything below this or above that would be considered an outlier. And then other things from chapter 1. If the shape of the data is skewed, the tail points in the direction of the skewness. So hopefully you remember that, right? If it looks like this, well, I kind of didn't skew it a lot, but if that tail is going to the left, so that would be skewed to the left. Okay, right. That looks so, W looks weird. And if it was like this, then that would be skewed right, because the tail goes to the right. So make sure you don't, it's not where the majority of your data is, it's where the tail is. If the shape appears normal, you must describe it as approximately normal, because it is not officially normal unless you did some test or condition. The range is a single number. Okay, it's max minus min. It is not, if your lowest number is 10 and the max is 80, you don't want to say it ranges from 10 to 9. Why did I say 80? Because I was thinking the range. Max number is 90. You don't want to say it ranges from 10 to 90. You want to say the range is 80. Okay, and so then the mean and standard deviation are strongly affected by outliers. So that's why if it's outliers or skewed, you don't want to use mean and standard deviation. So here are your options for measures of center: mean, median, mode. We don't normally use mode, right? So honestly, when you're in chapter, we use mean probably the most, but when in chapter 1, we probably use median the most, in my opinion. And then measures of spread, you could either talk about range, max minus min, interquartile range, which would be your Q3 number minus your Q1 number. You could talk about variance, which is just your standard deviation squared, right? So if standard deviation is S, variance is just S squared, or sigma squared. Now you notice the things that are starred are not resistant to outliers. So what does that mean? If you think about a set of data, let's say 5, 8, 9, 10, 10, and 15. Now, if I say, okay, now actually that 15 is wrong, that 15 is supposed to be 100. What would that change? Would it change the mean? Absolutely, right? It would make the mean greater. Would it change the median? It wouldn't, because if the middle would still be 9.5. It doesn't matter how much larger that number is. So median, if there's an outlier, is the best option. I'm going to say best for outliers, because it is resistant to outliers. It does not change. Would the mode change? No, but again, we don't really use mode. And down here, range would obviously change because now your max is 100 instead of 15. So that's why you would want to use your inner quartile range if there's a huge outlier, because that wouldn't change. Your Q3 is still going to be, let's see, that would be 10, and this would be 8, and that's not going to change. So your inner quartile range, no matter what, would be 2, no matter if that got really big or this got really small. And variance and standard deviation would also change if you were to do the calculation, which for those, you do have a formula on your formula chart, but I would always recommend you can use your calculator and type that in a listing spreadsheet and then do one variable statistics, and it'll give you the standard deviation if you ever need it. Okay, so then another thing, which I want to say this is more in chapter 2, but transforming on center and spread. Remember, if you add a constant or subtract a constant, it only changes the center, right? By whatever that constant is that you're adding. So your spread is not going to change. Spread doesn't change. Now if you're multiplying, though, it changes both center and spread by that multiplication. So you got to do it to both. But if you're adding or subtracting, you're only going to do it to the center values. So that is a review of chapter 1. Now let's go ahead and talk about chapter 2. So chapter 2 is modeling distributions. This is when we got into those density curves and z-scores. And so the first thing we talked about was percentile, which is the value with p% less than it, right? So let's say you're at the 75th percentile. What that would mean is if you map out the curve, I don't know why I didn't go all the way down, but that would mean that you fall about right here and that there is 75% below you. That area is 0.75. Percentile is always less than. This value would be at the 75th percentile. So then the word relative frequency, you need to, whenever you read relative frequency, you need to associate that with, that's just a stats term for percentage. It's the count divided by the total, which you know is how you get a percentage, a decimal. So that is just another word for percentage. Now if it says cumulative frequency, notice it doesn't say relative. Okay, so without the relative, it's just a count. You don't divide by the total. But cumulative means you add up the counts in the frequency column for everything before it. So it's the same idea as you add up as you go. So if there's 5 here and that's not going to be clear. We'll talk about that when we get to a problem. But just know you're adding as you go. So then when it's cumulative relative frequency, that is the same deal as percentiles. You add up all the percentage below it. Which I want to say you do. In chapter 2 you have an example of this if you're kind of getting confused. We did a good example that relates all of that in chapter 2. It says 87 on textbook, but if you just go to your notes, I think it's the same thing. But notice this one, because it said relative, we divided by total because we're getting percentages. Okay, so z-scores are important. When you find the z-score, it's called standardizing. So you're measuring how far an observation is from the mean, which it actually goes back to this test statistic formula that we used in the later chapters. But to find a z-score, how many standard deviations your value is from the mean, you take your observation x, you subtract the mean x bar, and you divide by the standard deviation s sub x. That is your formula to standardize. And what that is it's the average amount of standard deviations your value is away from the mean. So if you have a density curve, they all have an area under 1, and it describes your pattern. So you need to know that this peak right here, if it is perfectly normal, then that peak is the mean, the median, and the mode. All those would be equal. Now once it's skewed, so this would be an example of skewed left. Remember, the mean is pulled out into the tail more than the median. So the mode stays at the peak. The median is pulled, so what the median technically is, it's equal area, 50% on the left side and 50% on the right side. So it's going to be pulled a little bit. Maybe I should be writing sideways. And then the mean is technically the balancing point, which doesn't add up. I don't really know a good way to describe that. All you really need to know is it's going to be pulled the most into the tail. And then if it's skewed right, same idea. The mode would stay at the center, at the peak, not the center. The median is pulled a little bit more, so there's 50% of area on each side of it. And then the mean is pulled the most into the tail. And there is no real way of knowing exactly where that mean would be. You just need to know that it's pulled the most. So if it asked you in which one of these scenarios would the mean be greater, well, here, this is a number line, so here the mean is less than the median. Here the mean is greater than the median because it's on the right side of the mean. So we would know in this scenario, this skewed right distribution has a greater mean than median. So the notation for a normal distribution curve, you can put a capital N, comma, parenthesis, and you put the mean, comma, standard deviation. And so that the mean is just your center, and the standard deviation is technically where the point of inflection are when it's going to change from concave up to concave down, which we haven't really talked about that. You can just tell, like down here, how much you go over, and it should be about 3 standard deviations till you get to like the very edge of your density curve. And now if it says standard, normal, standard means the mean has to be 0 and the standard deviation has to be 1. Okay, normal, it can be, the mean and standard deviation can be anything. Standard, it has to be 0 and 1. It means you took all your data and you converted it all to z-scores. So now if you do that, then the mean is going to end up being 0 and your standard deviation is going to be 1. And the same idea. So then how do these compare based on what is a larger standard deviation going to do? It's going to widen out the curve, which this is actually very applicable to everything going on in our world today, and flattening the curve. But if you have a larger standard deviation, it's going to, because the area has to be 1, so if there's more variance and it widens, then it's going to have to be shorter, right? And then if it's taller and skinnier, then there's a smaller standard deviation. There's less variance. It ranges less. So this would, if they asked you something to compare these, you would know that this has a larger standard deviation and this has a smaller standard deviation. And one of the other things in this chapter was empirical rule, which just guarantees that any normal curve, if you start in the middle at the mean, you go 1 standard deviation away on each side, that's going to be 68% of your data is going to fall in between those two values. If you go 2 standard deviations away, 95% of your data is going to fall between those two values. And if you go 3 standard deviations away, 99.7% is going to fall within those. So it kind of helps you break down your standard deviations, and if you look at a curve base, what your standard deviation is. Also, you could probably get away with not knowing this if you use the calculator, but I feel like they can find ways to ask about that topic with it. So you need to be aware of that. But if you don't remember that, you can always do it in the calculator. So how do you find area, which is also going to be the same as if it asks about probability or percent, that's area, between 2 points. That's when you go to normal CDF. So for example,